Can you see my screen now?
Sudah, Bu.
Right, so for today, we are going to discuss building construction, specifically in the system, materials, and its process. It is something that you have to understand that when we studied about structure, we also consider the construction as well, because when we are doing the design, we have the intention to make our design is built, so that we have to not only think about the structure, but also the construction. So today I will cover about 4 things actually. The first topic is about building construction itself. Next will be followed by the structural design. And then the third topic is structural planning. And the last one is about construction process. When we are talking about the system and also materials that we are going to use in the building construction, I covered it in the structural design and structural planning, because these 2 activities related to the system. You have to pick the system, you have to understand the system that's suitable for your building, for your design. Commonly practice, a student will tend to design their building first and then think about the structure later on. But during the practice, I believe that you need to integrate those skill, whether you are designing or designing for your architectural expression, but also you have to consider the structure directly with those consideration. So this integration makes you not feeling really hard to get the structure itself, but don't limit yourself because of the structure as well, because sometimes when you try to integrate the design process with the structure, students tend to get very limited. But again, when you have the rule of thumb of the structure, then you can improve your design itself. Well, yeah. Next is about the glossaries. Today we don't have a lot of terminology. We can use the previous terminologies that you have that I have given you in the previous meeting. Today, maybe there are some new glossaries for you, such as pin or hinge joint. So, and then roll joint and then rigid or fixed joints. In the joint itself, sometimes you can use this pin or hinge, roll, and rigid or fixed as a support. So sometimes you can mention that it is pin or hinge support, roll support, or rigid or fixed support. So if we are talking about support, means that we're using it as in Bahasa we use it tumpuan. So it's literally the translation. So when you are talking about pin or hinge joint, means that it is sambungan engsel or sendi. But when we are talking about the support, then means that it's an engsel or tumpuan engsel or sendi. So it applies for the roll joint and also rigid or fixed joint. And then next is welding. Welding is this, and then hip rafter, and then pattern. During the traditional practice and also the international, I don't think that it's international. So the book we used, majorly coming from the US and also European country. When we try to adopt this with our common practice in Indonesia, sometimes the terminology changes, and sometimes there are some part that is not doesn't exist in the US or a European country, but exists in Indonesia, and sometimes otherwise. So I hope that in this process, I will try to show you a general one, but also I will give you an example of how we conduct a building construction process in Indonesia first, because I don't think that, I think you can find a lot of example of this process, not only in Indonesia, but also in the European and US based practice. So let's move on to the first topic, which is building construction itself. This is I will discuss about the building construction in general so that you can understand how we conduct the building construction itself. Even though we are architect, but we have to think about the building construction as our additional consideration to our design, because when we are talking about our design means that our design must be built. So if we are talking about the buildability of our design means that we have to think about the structure and how to construct them. So when we are talking about the structural, then we come to two things that related directly with the building construction. First is about structural design. Oh, can you see my mouse? I think because I'm using iPad. Wait a minute. It's a pen. Yeah. So in the left side, you see there is a structural design. On the right side, you have the structural analysis. These two activities directly related to the building construction. It has a different nature, so you have to consider this. Usually, architect only considered about the structural design, while the structural analysis done by structural engineer or civil engineer, because it's more like calculation about the ability of the structure itself. So the structural design revolves around the activity of arranging, interconnecting, sizing, and also proportioning the structural elements and also the system so that it can make a good assembly to support the load. And then otherwise, the structural analysis is talking about the determination of the ability of the structure to support the load so that it doesn't deflect or deform because of the excess load imposed to the structure. So these two activities is really important when you are trying to construct a building, because you at the beginning you will design the structure, and then before directly to build it, you have to do the analysis to make sure that your design, specifically in the structural part, can fulfill and not access the allowable deformation or deflection from the structural elements. But based on this nature of these two activities, so I think you can understand that for the structural design, the starting point is in the bottom. So we can mention that it is a bottom-up approach where you have to think about the substructure first and then goes up to the superstructure, because it directly represents the building construction in real life. So when you build a building, it is started from the foundation and then goes up and it goes up until the roof. But on the other hand, for the building, the structural analysis, it's going top to down part, because you have to analyze the building load and then also how it will be distributed through the elements to the ground to get the reaction that we mentioned in the previous meetings. That's why when you do your assignment, your first assignment, there are these two activities. First is the structural design, because you have to make three-dimensional model for your selected case, so that after that you try to analyze the structural composition. By doing this means that when you are building the model, you are going to bottom up, while for the structural analysis, you're going top down. So those are the basic thing about the building construction. And now when we are talking about the structural analysis, there are some considerations such as the arrangement, shape, and dimensions of the members, which is done in the structural design. And then also the types of connections and supports utilized. This is also done in the structural design. And then last is the allowable stresses of the materials employed. when you are selecting materials for your structural design, then you have to understand the properties of each material. When you understand the properties of each material, then you understand how it can, whether it is resistant to torsion or tension or compression, so that you can assign those materials in as a suitable element in your structural system. These are the structural analysis consideration. So before you did your structural analysis, that's why you need to design your structural configuration. So that's why we are talking about a search for a structural system that can meet not only the load requirements, because it is talking about the structure, but also address the architectural or maybe urban design and also pragmatic issues at hand. We are talking about here what makes us different with some. I got from new student, I got several questions. What is the difference between architecture and civil engineering? And this is how we are really different in terms of what we are considered. We are considered not only the structure, but our main goal is trying to provide the architectural expression, while the civil engineering or structural engineering, they try to understand how the buildings stand, so that they can calculate the load, the reaction, and also the forces inside, and the right material to use that efficiently. While for us, that's what the civil engineering did, is something to consider when we are doing our design. I think that's all for the building construction part. So those are the overview about how we try to construct an understanding and how we try to understand the process of stages when we want to build our design. Next, move on to the structural design. Here, I started to discuss about the systems and materials used when we are talking about structural design, because in this part we have to think about the arrangement, proportion, size, and also interconnection between elements. In the previous meeting, I've given you an overview about the elements that needed to address when we are designing a structure. And now, after you know the system that you want to employ in your building and support your architectural expression, and then now you have to think about the construction itself. There are some systems and also materials. The system itself refers to the connection between each element, so that when you are trying to assembly something, means that, again, starting from a smaller or like units, and then you try to combine those units into an assembly. So at the beginning, we are talking about the arrangement. So the arrangement of structural elements here in this activity, which is the design, we have to think about the nature of the architectural design. We take a look at the type or configuration or pattern of our design. So how our expression of the design affect the structural arrangement. I will talk about later. I will talk about it more in patterns, I believe, because when we are talking about structure, we are talking about efficiency and continuity, so that it can support the load that imposed to the building. And next consideration is site and context. We have to think about the structural responses. So site and context mean that how we can understand the site itself, like topography maybe, and also the context, how big our building is and how many people will inhabit those buildings, because it will define the structural response that we have to think about. And then next, the availability of certain materials, and it affects the building code requirements, supply, availability of labor, and also cost. For the building code requirements in Indonesia, you can find SNI. So in SNI, you can find different type of materials can be used for building construction, such as steel, wood, and also concrete. And each material has their own requirements. So when you are trying to employ those materials into your structure, then you have to take a look on those things. But I will not explain it detail on the requirement here. Next is about the interconnection. So after picking the elements that you need you need to utilize for your building, specifically for expressing your design, then you have to connect each element so that it becomes a system that works for you. So there are several part of we call connection. If we are talking about the elements that connected, the condition of the elements, there are three parts. There are three types. First is butt joints, second overlap joints, and then the last one is molded or shaped joints. While if we are talking about the medium of connections, we have to think about there are three parts, which is point, line, and plane. For the point, we can call it bolted connections. And then if we are talking line, it's a welded connections. If we are talking plane, it's like a glued connections. So this is what we call butt joints. So the butt joints is actually one element to be continuous, but also it requires a third mediating elements. Material can be used here, wood, metal, or concrete. It's just like in your here. So you have one part here, you have another part here, you have other part here. It's just trying to stick the butt. This is what we call, why we called it butt joint. So as easy as that. Next, this is the example of butt joint. So it can be like this when you have like whole wood like this, or it can be like this. It's chopped into diagonal and then glued like that. Oh, a second. And next, for the metal itself, usually it's welded. As you can see here, there is something here, so it's an addition to make them glued, right? So and then this one as well. So you have this part actually added by this part. So basically, butt joint is talking about joint where you don't have to reduce or overlap or whatever you do for the modificating the elements. It's just trying to stick each other, something like that. Now, when we are moving to the concrete, I think this is the illustration, because if we're talking about the photo, I don't think that it works well. You can see the difference, but here is a butt type construction joint for a concrete. So sometimes if you have, for example, this one, an old concrete, and then you need to extend the house or the building, then you add another concrete here, new concrete. So again, if butt connection, it's only this, but you can do additional you can add additional strength for this type of connections by adding some metal here so that it stick more. And also for the wood, usually you can use glue or maybe bolt, or also other thing like a third medium like a plate made from metal, so that you can just cover this up like this and then add a bolt here. So something like that. But the point is, butt joints is only trying to connect this in the whole material, as a whole material. And next we are talking about the overlap joints. This is I think you can get from the image that the overlap joint is actually just trying to overlap the elements as a whole. So there is no modification here. How to join it is using maybe tie. You can tie it down, or maybe you can use bolted, or also glued is okay. The material here is wood and metal. Well, when we are talking about concrete, well, you can use the overlapping joints here, but it's not that effective because, as I mentioned in the previous week, that concrete is actually having very unique characteristic. It's fluid and then become solid. So when it is flexible, then why you should put it like this? Usually this one, the overlapping joints is used for materials that cannot be change the shape, like wood or metal, that you have to just directly combine them. This is the example of the left side here is the example of wood, the use of this overlapping structure in wood. And here is and the right side is example when we are using it in steel or metal. So there is always this type of welding here, additional things to so that it can attach each part together. While this one, you can use glue or you can use a bolt to combine these elements. Next is molded or shaped joints. So molded or shaped joints is something is a connection that creates something like this. You have the hole, and then you have something that goes into the hole so that it can fit. I think when you go to IKEA, maybe I don't know whether IKEA has this type of furniture, but an old furniture such as I believe such as bed, furniture for bed, still use this type of connections instead of only use the bolted one, because it is stronger, so that when you try to join each element become the bed frame, it's really rigid. So that's why the example is wood. Doesn't mean that metal is not available of doing this, but it takes a lot of effort if you try to shape the metal. And also concrete, why you should shape this concrete like this, because concrete, again, it's coming from fluid and then going to solid, so that it's not effective to use this one for the concrete one. So this is the example. The hole that I mentioned before called mortise, and then something that protruding to insert in that hole called tenon. I think this type of connections or joints can be found in traditional construction. Maybe if you have houses made from wood, specifically for the, I don't think that you have still you still have those type of building, but specifically for the roof, you can use this type of joints. But other part of the house can also use this shape of joints, because it can create join. Well, when you talk about wood, wood, it has limitation, so that for example, maybe maximum 9 meters or so, maybe if 9 meters, and then you have like 18 meters of span, then you have to join it, and then this type of joint work really well with that. And then for the medium that I mentioned before, I think bolted connections, you have understand this bolted connection, because every time you buy furniture and then you try to build it by yourself, they are using bolted connections. And then welded connections like this, and then glued connections is using like specific glue to come to stick those elements together. For example, you can find wood glues or also metal glues, but for metal, people believe that welded connection is stronger than the glue. But for wood, you don't have any options rather than bolted or glued. Next, if we are talking about the connection between the elements and also medium of connection, for butt joints, you can use three type of the connections like bolted, welded, and glued. While the overlap joints, you can also use the point, line, or plane as well. But you have to consider which what materials to use. While molded or shaped joints can use this type of connection as well to add more support or to add more strength for the connections. So while I don't mention that it is not allowed, I didn't write it because sometimes when you use molded or shaped joints, then it is enough. But if you want to add more, you can use bolted connections or glued connections. Next, we are going to talk about the interconnection again. And this is the type that will be used maybe to understand the system of construction. So this is very important. There are four mainly in the building, but for simple buildings, we have three, which is pin or hinge joint, roller joints, rigid or fixed joints, and the last one is cable supports or anchorage that usually used for wide span building. So the pin or hinge joint, the characteristic is because it is like this. I will give you the video and at the end of this part, because the image, maybe you didn't have the image of how it actually works. So for the pin or hinge joints, it allow rotation because it's pinned here and also here. It's attached in this part and also this part, but it allows rotation but resist translation, means that it doesn't allow itself to move left or right like this. So if it is allow rotation and resist translation, then it means that it is able to resist vertical and horizontal load but allow moment. But the limitation is it cannot stand by its own, minimum two supports. So imagine that you have this type of joint or support, then you don't have anything here. And then when you push it or from the below part or maybe the upper part, it is easily for them to rotate like this. Next is we're talking about the roller joint. So the roller joint, it's allow rotation but resist translation in the direction perpendicular into our way away from its face. So you can pull it and then you can just slide it to the left or to the right. So it is able to resist vertical load but does not resist horizontal load. So if you use this, then it cannot resist the horizontal load. The limitation is it needs other support to resist the horizontal load because it is free, moving free from the left to right. Next is about rigid or fixed joint. So this is a joint that really rigid and fixed so that it is not allowing all of vertical, horizontal, and also torsion. So it is able to resist vertical, horizontal, and moment load. And that's why we usually use it for a concrete one. But the limitation is this type of joints not suitable for structure that needs deflection to maintain the geometry caused by tensions. For example, you are using it for a bridge or maybe a cable, then you cannot use this because those structure usually have deflection because of its material that they use. And then when you use this, it will break down and it's not allowed to use that. So next is cable supports or anchorage. I think this is something that you will learn more in following years, but I can mention it now. So this is allowing rotation but resist translation only in the direction of the cable. So this is the anchorage, and this is at the edge of the cable supports. And now I will give you An explanation about those joints. This is an animation so that you can imagine what does it mean by not allowing rotation, and then resist vertical and horizontal load. Tell me if the sound is working or not, because I'm not sure that I have input the sound when I share my screen.
They can have pin supports.
Can you hear the sound?
Iya, kedengeran, Bu.
Okay, right. So sorry. Oh, but now why? Wait. I cannot hear now.
They can have pin supports, roller supports, or be fully fixed, which each restrain the beam in different ways. Pin supports prevent vertical and horizontal displacements, but allow rotation. Roller supports prevent vertical displacement, but horizontal displacement and rotation. Fixed supports prevent all displacements and rotation. If a certain degree of freedom is restrained at a support, we will have a corresponding reaction force or reaction moment at that location. For example, rotations are permitted for a pin support, so there is no reaction moment, but displacements in the vertical and horizontal directions are prevented. So we will have horizontal and vertical reaction forces. So how do you determine the shear forces and bending moment?
Right. I think those are how you actually try to imagine how this type of connection or support work. Again, when we're talking pin, roller, and also fixed, it's not only talking about the connection, but it's also talking about support. Well, in general, it is a connection, but when it is positioned like for beam and column, then it means that it becomes support. That's why here is another example. I will explain it to you. This is a beam, this is beam, and this is the column. If it is not reinforced one, which is for example, made from concrete one, that it is connected directly, so it is separated. So you have this element separated from this element. So the A element and B element is separated. Then you have hinge support here or pin support. Why? Because as you can see here, when I give you the force here or load, it will be transferred first going here and then goes down and then pushed by this one. The reaction is going that way. For this part, for the vertical part, you can resist it, because it gives a reaction here. But again, when you see that this is when we're talking about the horizontal load or the lateral one, you see that there is no there's no something holding on to this, so that you can find that this structure will going to move right and left. That's why this is called the hinge or pin support or joint. And then for if you find this type of example, like as you can see here, this is working almost like the same in the previous image, which is hinge or pin. But this one is, sorry, this one is roller support. Because as you can see here, when we are giving load like this, it transfer like that, it is free to move to the right, but this one, you have something stop it here. So that's why we call it roller support. It is happening because if we have the elements not connected each other, I mean, it's separated. While for our practice, like using concrete as a frame or bay or column and also beams that is directly reinforced each other, so it becomes a fixed joints. So those are how you can find roller support or roller joint, and also hinge or pin. In civil engineering, it's just for your information. For the fixed support, the symbol is like this, just like this. While for the roller support, it's like this. For the hinge or pin support, it's like this. So like that. So that's why when you try to find the civil engineering, trying to calculate the reaction on those in this type of structure, then you will find this type of symbols. So those are what the connections looks like, or the system that you're going to work on for your building. Now we move on to the sizing and proportioning. Again, after considering those systems that you are going to use, you try to understand how big is the column, how deep is the beam, and it relates to three parts. First is about the support options. Second is about spanning options. The third is about lateral force resisting element. Again, the support is related to the main structure that holds and also give strength for the building or the configuration, while the spanning helps to divide the distribution of the load so that it can be safely transferred into the main support system. And then the lateral is working for the horizontal load that usually happens because of an earthquake. For the first thing about support options, we are talking about column. We are talking about girder. Girder is like a beam, like it's a beam. And then also we're talking about bearing wall. So anything related to this main structure, such as those, is related to the support options. If you are talking about this two columns added by a beam like this, it's called bay, one bay, or framework can be. So, and then this is the series of column. Bearing wall is actually when you find that each column, you have a, a specific span, for example, like this, and the span carry a big load, like so that it needs more column beneath it. And if you find that you need more column like this, instead of just using column like this, you just use bearing wall instead, because the distribution of the load, it can be transferred through all of this part of the wall, because it acts as a medium to transfer the vertical load. What I mean by the distance is getting shorter is actually trying to get it more efficient. For example, you have several columns, maybe the distance is only 15 centimeters, which is not allowable for us to inhabit, such as for circulation, for anything. Unless it is your expression, then you can use it for efficiently using the bearing wall rather than a series of columns. So again, we are talking about efficiency in choosing what type of support and how can we arrange them and also assemble them into a system. Next is about the spanning options. So the spanning options help you to bridge the space between the support systems and then also distribute it to the supporting planes. There are two way of spanning, one way or two way. Okay, so pattern of spanning, there are one way and also just two way spanning. So the one way transfer applied forces to only one direction, while the two way will transfer the load into two directions, usually perpendicular to the assembly. So this is the example of one-way spanning system. What it means by spanning system is, imagine that you have this type of framework here. This is one framework and this is another framework, and you don't have any support here. So it means that you have one-way system, because the spanning system is only holding on to this direction, so supporting this direction. Ah, my image is getting first. Wait a minute. So as you can see that the spanning is only in this direction. It also applies for this one, because you have this only and this only, this only. You don't have any, this direction is not exist. So if you have forces in this way, there is no any elements that resist those load or those forces. It applies for this configuration as well. So one way means that there is other part that is not supported by the elements. Next is the two-way spanning system. As you can see here, each part of the column here, like this, is connected by beams. And this helps you to fight for the forces from here and also here. So that's why it's called two-way spanning system, because it acts it responds to the perpendicular forces like this one and also this one. That's why you need to it depends on what building and how you will inhabit this building and the activity inside, whether you choose between a one-way or two-way spanning system. But for the safety during the building, commonly used system is the two-way spanning systems. Next is about the pattern of lateral force resisting element that we mentioned also in the previous week. So there are 4 patterns here. First is diaphragm. Horizontal diaphragm is actually like a slab. When you see it in the real life, it's literally the slab, like a concrete slab, that helps you to fight for the lateral forces, such as this part. I forgot. And then for the braced frame, can be like this. It's actually just holding on the framework that they are having, because when you push this way, as I mentioned before, because it's not attached, it has a hinge or pin support, then it can move. It can move to the right or to the left. To prevent those movement or translation, then you have to use braced frame. And the next is moment frame, where everything is combined together like this, so that it is rigid or fixed joint. And then the last one is shear wall. So shear wall is like a moment frame, but fully created like this. So this is the shear wall. It helps to not only the lateral forces, but also helps the vertical and also horizontal loads. Next, we're talking about structural planning, which is also talking about the system and also materials. For the structural planning, we have to think about the redundancy, the continuity, and also the assembly. What we are talking about here is trying to make the structure as efficient as possible, because if it is efficient, then you don't have to think about the failure of the construction because of malfunctioning. So what it means that redundancy, continuity, and assembly, as you can see at the right side here, each element is actually continuous from the top to bottom. So this is the final assembly. And then as you can see here at the top, each part of it is directly continuous, like so there is no protruding part. This is called efficiency. But if you have design, like for example cantilever or something that is not regular like this, then you can do that. But you have to think about how the load is transferred into the building, so that into the element of the regular one, such as this. So that, for example, you have something like cantilever like this, you have to think about how the load here can be transferred into this main structure. So those are what we are talking about: redundancy, continuity, and also assembly. Those are the consideration when we're talking about the planning. That's why if we are talking about the continuity and also redundancy and also the assembly, we are talking about the grids. So if we are talking about the grids, it's something that's, well, usually students forget about the grids. So when we are talking about structure, that we have to understand the coordinate of each elements. So we are not just plotting that, okay, this one in this place, this one in this place, but we are talking about its coordination. So the coordinate is here. When you try to, the meeting point between the horizontal and also the vertical line, it represents, in plan, it represents the columns, but also if you goes up, it represents the beams, how the beams will span. So these are why structural grids is really important. The type of structural grids is so, there are so many variations of structural grids, such as, for example, you see here is a regular grid, which is a square grid. When you see that each side is the same. So the grid characteristic here, you have to consider the proportions, the structural bay, material and structural choices, because the grids like this, you have to understand how big it is and how big it is, and it directly affected the materials you use and also the structural choices. For example, concrete has very strong one, but compared to the steel that has lightweight one, the strength, the steel strength is stronger than the concrete in terms of the span. So when you're talking about building, then you have to consider whether you use concrete or steel to create the structural choices. And also dimensions, it's not only about direction of spans and span length, but the materials and type of spanning, so that the greater the span, the deeper the spanning system will have to be. For example, like this, you have maybe 2 meter span. This one is 2 meter. But if you want to create one element, like a continuous element for 4 meters, it means that the deep here is going to be added, like the deep here. So it's going to be a lot deeper because it supports a bigger span. So that's why dimensions is really important. And also scale. So scale is related to human activity accommodated in those space, specific space. So you are talking about the efficient span range or nature of the foundation of soil. So for example, you have a building. This is it. It usually happen in students when they design 2-story or 3-story building, and then they just use the height of the floor to floor is 3.5 meters, for example, like this. If you have people here, and then this one is 3.5. When they are considering the span, for example, you put the column here and then also here, and it is so far away because they want to create a free space, a free arrangement here. And then when you try to calculate this, and then suddenly the beam becomes maybe 500 millimeters, like this. So efficiently, you only have 3 meters for the room because you have this beam. So again, when you try to accommodate the structure and also your height of the building, you have to consider about the structure itself. That's why scale is important. And then also spatial fit. So again, like this, sometimes because you forgot that you have the beam that you have to consider in your building when we are talking about the volume, when suddenly the height of your floor to floor design is not sufficient enough for the beam to be there, then you create some spaces that cannot be accessed because of the deep of the beam. So those are another consideration for special fit. And then next, we are talking about the type of grids. As I mentioned before, there is regular grids and also there is irregular grids. For the regular grids, as you can see, there is square grids, rectangular grids, tartan grids, radial grids. So for the square and rectangular grids, here is the example. I mean, square and rectangular is almost the same, but for the rectangular one, you have other sides like a little bit longer like this. So, but it's still in the regular one. And then for the tartan one, it's like this. It's like a tartan motif. So usually the tartan here, let me zoom in like that. To make it efficient like this, you use it as a mechanical housing. So you put your pipe, water pipe, and also electrical inside this type of structure because it's not habitable, so that you can use it for mechanical stuff that will help the building to run. And the next one is radial grid. So radial grid is like this. You can choose whether the span is like this or like this. If you choose to span like this, it means that it has the same span. But if you choose like this configuration, then each span will be different. Like the first radius is this big and the second radius is this big. So those are the regular grids. You can find the example of this building in the books. There are a lot of this. And then next is irregular grids. So there is modifying grids by using addition or subtraction, scale and proportions, geometry. And then also there is a contrasting geometries that is kept separated or maybe overlap and maybe incorporated. And it is also applies for the contrasting orientation. So it means that the irregular grids, it actually doesn't have to be categorized like this. The irregular grids is the grids that, well, it's obviously clear. It doesn't have any pattern that you can see. But again, to create the grids, still you have to create and select a significant edge or linear condition of which one can orient the grid of framing pattern. Even though your building is irregular, then you have to think about how to make it a little bit regular or regulated. Because when we are talking about building construction, we are talking about the real life process. And then when you have, for example, property line like this, and then you have a building like this one, how can you build this type of building inside the property line if you don't find the grid? So you need to define the grid, and then also maybe the starting point is here, and then how big is it, what is the distance from the property line. Those are the function of the grid. Another function of the grid is not just trying to define the structure, but also it expresses the elevation itself. So for example, I was in charge on a project. Well, it's, I don't know whether it's already built because the project is on 2018, but unfortunately I can show you the image due to the copyright from the company that I worked on previously. It's a project that maybe when you come to our campus, then you can see it. I hope that it has been built based on my design. I don't know because I left the company in 2019. It's a mall, like a small one. So the mall is located in Mulyosari. Mulyosari is near our campus. Beside the gas station in Mulyosari, there is called Lagoon Mall, Lagoon something. I forgot. So the building itself is the shape is, as long as you remember, it's almost irregular. This is the first floor, and then the second floor is about like this, and then the third floor is another shape. So in this type of configuration, even though this is for higher building, but you have to understand the importance of grid here. So how you can create this type of grid is first trying to find the radius of this curve. For example, you create like this. So this, you have to define where this dot stands in the side, and then you find the radius and then try to find how long it is. The grid here, for example, I have created the grid A and then also B. It applies not only 2 dimension but 3 dimension. So when creating the facade, I was in charge for the facade development. So when creating the facade, then you have to define the facade like this. So when you are creating the facade, you have to create like this, because the facade itself has different type of finishing. For example, like this, this is the cladding, as long as I remember, and then this is the stone. So and then we are talking about, for example, this is B, and then this is A. This is the function of the grid. You define each section of the building. And then also back then I use Rhino instead of SketchUp, so that you can unroll this type of building. Because when you are designing this type of envelope, again, even though this is if you find that the building is squarish like this, it's a lot easier for you to build the elevation or the facade. But while you are having the curved one, you have to unroll this curve and then trying to make it like planar like this, so that you can create those type of distance, for example, connections and stuff. So this is how you use the grid. So not only just trying to define the position of the structure, but also trying to express how you want to build your building. So it's not just, okay, I just want to have a curved one, but how to create the curved shape become reality is something that you have to work on. So that's why grid is really important, whether it's a irregular grids or regular grids. So try to make it as logic as possible, so that you can understand how you build it. Just imagine that you are building it by your own hand, and then try to build it from the bottom, and then it goes also going to the top. I think those are for the structural planning. Next is about the construction process. So this is where you can find this example. It's an example of a very simple house, simple building. So this is the construction of 1-story building. At the beginning, this is an empty plot of land, and then followed by excavated with the shape of a prism in a certain size. So the function of creating an excavation here is trying to build the footings or the foundations. Why it should be prism? Prism means like this. And this is the original ground. Oh. So why it should be like this? Well, it's actually for the practicality for the people who build our design. If you have like this, well, it's workable, but for a building with 1 or 2-story building that built by not machine, but only people, for example, it's really hard to reach this down part. So if you create like this, people can just access it easily. So it's just for the convenience for the technician there. And then next, after you build the excavation like this, you try to fill it with sand and stone. Here is the sand and stone. This one trying to give additional strength for your footings. In Bahasa, or when you are talking with the technician, when you are building the your design, is called sirtu. It comes from pasir and batu, just like that. So that when you are talking with them, like, what is sirtu? And then you understand that it's actually pasir and batu. So this is like the foundation. So before you build the foundation, you put the sand and why is it sand? The sand and stone to create a base for your foundation, and then on top of that you put an empty gravel. Empty gravel means that you add gravel more to on top of that, but without any sand, so that it creates a working floor. A working floor here we call it aanstamping. It's coming from Dutch, but as you know, maybe later on you will understand that we use a lot of Dutch terminologies for our building construction. So this is aanstamping. So you create this working floor actually to add more solidity to your base of the footings. And then next is you build the footings. This is wall footing made from stone. It's very simple and commonly used for low-story building. And in Indonesia, you can use it. You can call it like this. So those are what it looks like. So you build it, and then next on top of the footings, you have what so-called sloop. This is the sloop, the green one. This is the sloop. Well, sloop is actually like a beam, but it's on top of the foundation and below the wall itself. And usually it is directly connected with a column, because sometimes a small building doesn't need in practice they seldom use column, because this a little bit expensive. So it's directly connected like that. So it is become one with the column itself. So again, before directly put the wall into this type of foundation, you have the slope. It's a transitional part from the foundation to the wall. And then after the slope is built, you need to fill the hole here with soil, so that on top of soil you only see the slope like this. And then after that, on top of it, you start to build the wall. Well, actually it has something like this, the column here. And then from there, you start to build the wall like this. So when you are building the wall, and you have to consider another envelope element, such as windows and also doors. So to create windows and also doors, you have another type of beams, which we call balok latai. So it's actually helping you to hold on here. For example, you have more brick on top, so usually located here. So it will be like this to hold on this part. And also sometimes it gives you something like this as well. So it is holding. Sorry, I have a phone call. So again, when you try to build the wall and then also add envelope on it, then you have to create the frame of the door and also window made from the concrete itself, so that it can hold the filling, the wall filling, such as brick, to so that it doesn't collapse by itself. And then next, after you build the wall, finish the wall, you have another type of beam on top, which is called ring bulk here, the green one here. It's called ring bulk. And this is another beam that you use to support the roofing. So it's usually directly connected with the rafter. So this is an important part that you have to create this one, because the rafter itself cannot connect directly with the wall, because the wall itself in this case is not a bearing wall. It's just a filling wall where it doesn't have any ability to support transferred load. It just try to give a security and also maybe privacy by filling the framework here. So this is a ring bulk. And then on top of the ring bulk, you have the rafter. Just put the rafter there. This is the example of a squarish building. And then after you build the rafter, on top of the rafter, you have hip rafter. This is the hip rafter. Hip rafter, we call it jurai in Bahasa. So actually what it does is give the edge of the roof. So if you go back to this image, it is impossible for you to create the roof like this, right? So you have to create the roof covered this this type of configuration. So to create this part, you add hip rafter. And then next you have collar, so that you can hold on each part here. It doesn't move around because it has to respond to other forces, so that you have to add collar. After you add collar, then at the end you add patterns or rank. Rank, it's hard. So patterns is rank like this. So it's like this, so that you can put roof sheeting here, or maybe you can put other covering materials to put for your roof. Next is about the projections that you will be familiar with. So when we are talking about the process of construction, we also talking about how we can express it in the illustration. So in the left side is the two-dimensional illustration or projection, and on the right side is the axonometric, so three-dimension illustration. This is what it looks like, an empty plot of land. So you have this line. Oh, sorry, wait a second. I need to. And then after the empty part, after you have draw the empty plot of land, you have the excavated area for preparing your foundation. When you draw, it's like this. Why it's like this? Because the section is here, for example, or maybe here. So as you can see here, there are two holes like this. So it represents in this way. And then next, you have those sirtu or sand and stone down here. And then followed by the working floor or anstampeng on top here. It's very small. I think I'm going to zoom in. Oh, this is the maximum one. So as you can see there. And then you have the footing itself. So again, this is a simple, the simplest one from the footings that we have in Indonesia. It's called Fondasi Batu Kali. And then after this one, we are going to add slough. This is the slough. Well, usually if in real life, you have this type of column, right? But for section, it is impossible for us to cut the cut the column. So the section here is not cutting the column, so you don't see the column inside the section image. Here is what it looks like when you try to fill the land, sorry, the hole previously in this type, so that it is a little bit elevated from the original land. And then after that, you add walls and also create windows like this. After that, you add more finishing, so you just finish up the walls like this, and then add ring bulk on top. Here it's very small. So those are the structure that you are going to use to support the rafter on top. And then next you have the rafter itself, just put it on top. And then after that you had the hip, but the hip hip is like this. And then after the hip you have the batten, actually. Oh, the collar here is the collar. This part, I mean. And then after you have the collar, then you add the buttons and also the covering. So the button is quite small, actually, like here. I don't know whether you can see it or not, but it's very small. So those are actually how we construct a simple one-story building. And then if we are talking more about this construction itself, I have another example. Wait. I will show you the poster. So right, so this is a poster created for a project on building administration and and enforcement capacity development for seismic resilience. So this is a guideline for building a simple house that's safe, that has a high safety on an earthquake, because this paper or this poster is responding when you have under a severe earthquake on 2006, as long as I remember, in Yogyakarta. So this project is related to those disasters. So this one is trying to give a brief guideline to people with middle to low income who had been experiencing building collapse from the earthquake. So it's very detailed one because it's a practical guide. I'm not sure that I should translate it into English, because this configuration or this process is only applied for Indonesian context. When you're going abroad and the construction system is different, so it will not be used there, literally will not be used there. So that's why I don't think I need to put English translation on it, because there is no international students, I mean students from or foreigner, so that I don't have to translate it. But this one is the guideline itself. So at the beginning, as you can see here, it mentioned about the materials that can be used for the structure. So they are using concrete, but they are not using like a fancy or high tools or machine to create the concrete. They just use their own hands, because again, this project or this guideline is for middle to low income people. So the material is only just cement type 1, and cement type 1 is cement that is really good enough for the having those type of stickiness. And then you have gravel, and then also sand, and then you have to use wood that has this type of characteristics. And then for the foundation or the footings, you use the stone, because again, stone is the simplest and easiest foundation for the for the building in Indonesia. And then this is how the proportions of each materials is combined, like 1 to 2 to 3 and to half. So, and then they also created method to check whether the mixture is appropriate enough for the structure. So they use if your hand, so if this is like this, and so the mix is correct, but if it is too maybe too mushy, then it will be like this. So this is when you are going to use concrete, or if you are going to use mortar, this one is the proportions that you have to use. And then after giving this after the in this guideline, I think you can see that how you create concrete and mortar, so that it gives you the overview of each material that we use on building. Because at the same time, I don't believe that you have experience building house. Maybe if you have new house and then trying to visit when you are building it, and then you can see this process, but not all students are having those experience. That's why I want to show you just an overview of the simple construction process. Next, after you know the materials, then you have to think about the structure, the main structure. Again, there are several terminologies that doesn't exist in European or US based construction. So, for example, this one, ikatan angin, there is no called ikatan angin, but you know there's a purlin or bracing. So this is actually bracing that hold the rafter here, so that it doesn't move around. So, and then you have ring bulk here, as I mentioned before, and then this is the filling wall created by brick, and then you have column footings underneath, and then you have sleeve, and then for this one is cable. Gunung-gunung dari pasangan bata is cable. So this is called cable in English. And then bingkai ampik gunung-gunung dari bertulang, this one doesn't exist actually in English. So this is what it looks like for the simple building. And then for the foundation itself, it has their own dimension. Again, the dimension is for one-story building. If you have two-story building, it gets bigger, it gets deeper, depends on the soil itself. So this type of guideline is actually made as general as possible, so that people can build it as soon as possible after maybe they want to have their own housing or their own home back due to the damage from the earthquake. So that's why this team provide this type of guidance, so that it is easily understood by the technician there. And then they just use this type of footings foundation, and then after that they also determine the span between each column itself. So you create something like this. And then it is also very detailed when they try to explain what the material is, so that they can create it by their own. Well, again, it's not our responsibility to understand, to memorize all the composition or the proportion of each materials that can be mixed here. But again, it is for your knowledge that you understand how can we make concrete, so that when you supervise your own design, when you come to the site, usually you will directly talk with the technician, not only just mentioning your design. So if you don't understand this, then the technician will lose respect on you. So that's why you have to at least understand the rule of thumb of this. And then after you finish the foundation, you talk about the column, also the sleeve, and also the ring bulk, as well as the here is what we call balok latai. Here, I think you can see my cursor where it is here. So this one is what we call balok latai. So this one is holding on to the windows and also doors. So this is important for you to create this one so that your here your top your ceiling is not collapsed because it doesn't have the support below the support because of the window and also the doors existence. And then we here you find that there is specific configuration for each. For example, sloof, this is the size, but again, it's not your job to memorize this, but as long as you have those image, then you understand what it is made for. And when you are visiting a project, for example, you understand that those part belongs to sloof. And when you are talking with the technician, then you understand directly what they are mentioned. Because again, after several practice, I realized that standardized drawings is actually hard to read by the technician if we are working with Indonesian people, because they are not trained based technician, so that sometimes you have to you have to understand this part so that you can explain it correctly with them. And then this is the column. The column is quite small because the building is only one-story building, and it's only have the roof as the top, the upper part load, so it doesn't have any additional load. So the column is quite small. It's 15 to 15 centimeters, so that it can be just blend directly with the walls. So it's almost the same like the wall. And then next is our ring bulk. So ring bulk is the beam, but on top of the wall, like I mentioned before here, that support the rafter. So this is how it looks like and how it's sized. It is quite smaller than the sloof because it only acts as a medium to transfer the load from the roof only. So it doesn't have any additional floor on top, so that it's a little bit smaller. And then this is what how you try to create this, the reinforcement for the concrete. Well, you don't have to memorize this, but just take a look at this, because this is the practicality that they are using. Usually when you visit your building, the technician will bend it over using another type of this configuration to create this type of assembly. Next, after that, you see the rafter here. Again, the rafter itself, if we are talking about roof structure, in European country, they only use rafter, battens, and hips, maybe valleys if the floor is connected like valley. But Indonesia, there are several parts like this one, and then there are additional layers so that you can just hold on for the roof sheeting. So, but again, this is only something that you just to see, because this type of configuration is not commonly used nowadays in a modern building. Why? Because the wood itself needs a craftsman, and the technician think that it is not practical and it takes longer time than using metal rafter. So if you use trusses of or metal rafter, then the building time can be condensed and it's more efficient. And second one, it's more lightweight than this type of configuration. But for the traditional people, this one is more applicable for them and available for them in real life. So that's why they still put this type of information in this guidance. And then next, we are talking about the process itself. We are talking about the joint. Again, the joint is not, so this is the joint between each element in the practical life. For example, from the foundation with the sloof, you have to create this type of tie like this, so that it doesn't, when it doesn't move around. So in construction, everything should be rigid. So each element should be connected in such a way that they are not moving around. That's why they are using anchor, they are using maybe glued, but most of the time, if we are talking about a reinforced concrete, then people tend to use anchor like this, so that it doesn't move around. So this is the connection between the sleeve and also the foundation itself, because it's not just like when you are, what the game is, if you're building if you're playing the Sims and then you just build the wall and then also on top of it directly giving additional things. It's not just like that. When you're trying to build a building in real life, you try to assembly different elements, and those elements sometimes different, created by different materials, so that it has to be stick together by any medium, so such as anchor or glued. So this one is for the sleeve and foundation. And next is sleeve to column. So when we are talking about from the foundation, then on top of it we have sleeve, and then sleeve directly connected to the column. It's like this. So this is a column, and then how it connects with the foundation is sorry, with the sleeve is like this. So there's another anchor, but created from the steel here, so that it's like bent over like this, so that when you try to imagine, it doesn't move around like freely move around, because it's separated from the sleeve. So this is what it looks like. And then after that, when you are talking about the column and also the wall, here is, wait a minute, here is how you try to combine those. Again, you have still this anchor to the wall, because the wall itself, if you build the wall and doesn't have the anchor, then it will collapse again, because it's just giving you the fulfillment of surface, so that you can create your own space and definition of the space, so that to attach it with the columns, you still need an anchor like this. So this is how you try to assembly the column and also the wall. Next, if we have to that, and then here is another connection between column and also ring bulk on top, so that it's not just sit on top, but again, you have excessive steel here, excessive metal here, and then you try to just make something nested inside, so that when you put it on the concrete, so the concrete is becoming one. So the structure is connected to each other, not only just putting on top of it. Next, after the ring bulk connection, then you have how to connect the rafter and the ring bulk is this. Again, you need another medium such as this. So this is an anchor again. So here you just anchor it onto the sleeve like this. Oh, my connection is unstable. So this one is like this, so that it doesn't move around. Again, if you just put it, it will move around. Sometimes you have the anchor like this, or sometimes you have the plate here, here, and then just hold it like this, and then put bolt or anchor here as well. As long as it's not like moving, then it's fine. So the point is here, when you are having different elements, you have to make it really, really tight, so that it doesn't move around. Because again, continuity and also rigidity is the main goals for structure. And then additionally, you can to tie it down, and the tie is not created from rope, but it's created from metal. So it's actually anchored in the ring bulk here, and then you have this, and just twist it around like that, like this one. So those are how you make how you connect the rafter to the ring bulk. And then last one is the gable. Well, the gable itself is actually only giving you privacy and closing for your building, because it is the part of the envelope. So for the structure itself, it doesn't have any specific structure. But again, when you try to fill it with brick, so you still have to have the frame, so that it, because brick itself doesn't, is not able to stand by its own. So just it's the same, but added something like this. So like a framework, creating this triangular shape for the gable. This is how he made them. Again, it's not our job, but we have to understand this. So when we see it, and we know that, oh, they are building this part. So this is how they connect between the column, the ring bulk, and also the gable frame. Last one is the purlin. The purlin itself helps to give support for the rafter. So the purlin or bracing, it's literally like X bracing, but trying to connect. This one is the gable, and then this one is the rafter. So they give the purlin here. So it's like another support, so that your rafter doesn't collapse because of lack of support. So this is what purlin looks like, and this is how the purlin's connection looks like. So it has something attached to this part. So it is sunken. It is attached to the, not attached actually. It is planted on the wall like this, with with concrete for the reinforcement, and then it is protruding like this, and then attached with another wood to create purlin. So those are the purlin, and then that's it. And then you have those type of patterns on top, and covered it with the roof covering. Next is about how you do the concrete. So when you create the concrete itself, it's not, again, I mentioned before the prefab concrete, and also in situ concrete. So usually for this type of building, smaller building, they are using in situ one. So you create the scaffolding or the molding here. We call it pakisting. Again, it's maybe, I think it's Dutch. So this is pakisting. So it's like a mold that you create to shape your column, or maybe beams as well. So you just create something like this. First, you have to build this type of skeleton like this, and then you covered it with this part, the pakisting or the moldings, and then just pour the concrete inside that, and then leave for several days until it dries out and becomes the column, beams, or ring bulk. So those are how you create concrete. It's like this. So again, this is the vertical one. This is the horizontal one. So you have to finish the vertical one, and then after that you continue to the horizontal one like this. So you have those type of moldings to create the concrete. Yeah, I think that's all for the construction process. I think, oh wow. I think that's all for my explanation related to the construction process, and also systems, as well as the materials that you can use for the building construction. Now, time for question and answer session. So if you have any question or discussion, let me know. Unless I will ask you a question related to what I have explained. Okay, so is there any question?
Excuse me, Bu.
Yeah, who is this? Oh, Nadia. Okay.
Yeah. I'm not sure if this is a good question, but what about plafond, Bu?
Oh, how to build plafond? Do you mean?
Plafond. Yeah. Oh, yes.
Okay.
I didn't see anything about that.
Right.
So
So
I'm wondering about that.
Okay, thank you, Nadia. So again, plafond is under the rafter, but well, actually, I didn't cover plafond here because you will study it. This is just an overview. So the plafond will be covered in next meetings, which is superstructure and also roof. But I will give you an overview for the plafond itself. Wait a minute, I need to share a whiteboard here. So if you have, I will draw you a section. Oh. So this is a ring bulk. This is the ring bulk again. And then, for example, this is the, So this is what the rafter look like. Oh, okay, I'm sorry, because using mouse is terrible here in drawing. So when you're having this type of rafter, for example, and then when you try to build a plafond, ceiling, so we called it ceiling. Again, you have to consider the what is on top of it. For example, you have the beams. If one-story building, usually directly you have the ring bulk and then that's it. So it doesn't have any problem to create ceiling. Just put the ceiling underneath, and then also you have the framing. The framing usually made from metal hollow. Metal hollow is something like this. Like this, it's created from metal, and this is hollow. And then the size maybe 3 to 4, as long as I remember. So just you create something. This is a section. So you create something like this. Maybe it's like a frame to hold on it, to hold the material of the ceiling. And then how to attach this? There are some type of method that you can use. First is hang this with a sling, or sometimes you can use the same hollow to create this. So in 3D, the frame, it would be like this. And I need to concentrate for using the mouse. So this one, and then you attach the covering, the ceiling, from gypsum or anything else here. If you have specific type of shape, also you have to create the framing first and then cover it by the gypsum or other ceiling materials that you want to use. I think that's it's very simple, Nadia, for the ceiling. Is that clear?
Yes. Yes.
Okay. Okay. Any other question? No more question? Okay, Syam. Mm-hmm.
So it is related with my building. I want to ask a question. Have you heard about the rammed earth wall? And if you ever heard about it, how to implement to the building?
Rammed earth wall, right?
Yes.
Okay. So rammed earth wall is actually created by Adobe. It's like Adobe. Adobe. Wait a minute. I need to think about. So wait. I need to try to find the synonym that you are easily to understand. Wait. Hisham, what do you know about rammed earth wall? How it looks like? And then I will try to explain it for you in other synonym.
Based on my analysis, is like what? Seperti kayak bata yang ditempel gitu juga.
Oh, okay. Okay. So as long as I remember, ram earth wall is created by clay or maybe sand, soil that is rammed. I mean pressed so that it creates a solid wall. Do you understand this type of explanation? So it's related to if you are rammed earth wall is if I'm not mistaken, in the African they use their own soil that has a type of like clay to create their buildings. So if you think about bricks is actually from clay, right? But it's not for the brick you have to uh, burn it until it becomes orange. While for the rammed, they just use the clay and then try to compress it and just directly use it as a as a wall. Is that clear, Hisham? So the material is clay, but it's not the brick, but it's rammed, mean that it is directly the clay itself to create the wall.
So it is the same like dinding plaster itu. Apa?
Pardon?
Hello, yeah.
Oh, my internet connection is unstable. Yeah. Would you mind to repeat that again, Hisham?
So is it like the dinding plaster or different?
Oh no, a plastered wall is actually yeah. Wait a second. I'll show you. So if you have walls, when you create walls, when you build a wall, for example, from brick or red brick or concrete, whatever, it's usually having like an exposed one like this, and it's quite messy. And then plastered wall means that you add a plaster, another layer here from cement usually, so that it becomes clean like this, even though it's not that clean, but it's like this. And the plaster itself is also work for sticking the brick each other. Meanwhile, for the rammed earth block is not like that. It's just using the clay and then moving up like that. Is that clear, Isham?
Yes, it's good. Thank you.
Okay. Okay. Is there any more question? No question? Okay, if no question, then I will ask. Okay.
Can I ask the question?
Mm-hmm.
Does that mean every type of roof apply the same construction methods, or does it really depend on the form of the roof itself?
Sorry, it's a little bit low, your voice, Cindy. Would you mind to repeat that again?
Can you hear me?
Yeah, now it's better.
Okay. Does that mean every type of roof apply the same construction methods, or does it really depend on the form of the roof itself?
Okay, so first of all, it has to be related to the material that you want to use for the covering first. And then also the shape is also another consideration for your construction. But what I mentioned here first is the rule of thumb. If you have a pitch roof, we are talking about pitch roof, it always be there is a rafter and also there's a button, because rafter is supporting the roof itself, and then there's a button, and then the color is just additional. If you have the shape like I mentioned before, and then you have to hold each part together, then you have the color. And then if you try to build a flat roof, we don't talk about the pitch roof. Then if we are talking about pitch roof, then again usually the additional part is it depends on materials. For example, you are using tile, clay tile, genteng, yeah, clay tile. It's actually have more additional layer beneath, but because it doesn't have any terminology in English, I mean it's only in Bahasa, then you then I only show you that on top of underneath the roof sheeting you have patterns and then you have rafter. That's it. Because when you try to use a wood structure pitch roof, then there are additional type of what is that called, type of structure or elements that you have to add, like cording, and then what else, there are some type of it. But when you try to, nowadays we commonly use a metal roof, the lighter one, then you only need rafter and also patterns. That's it. So it depends on what material that you are going to use for the covering. That's my answer, Cindy. So it depends on the materials that you are going to use. Of course, the shape will determine how you use the configuration of the rafter. But for the general rule, you just need the rafter and then also the patterns and purling to make them hold together so that it doesn't collapse because of any lateral load. That's it, Cindy.
Okay, Bu, thank you.
Okay. Any other question before I ask you a question? No? Okay, then I will ask a question. So
Bu,
yeah,
I'm sorry, but can you repeat the elements connected yang butt joints, because my connection is unstable and that time, so I get miss that part.
oh, but joints.
Yeah, butt joints and overlap joints.
Okay, wait a second. Where is it? Here. So there are if we are talking about the joints or the connection, there are three. Well, actually, if we try to take a look at what is it joints and how it is joined, there are three types. Butt joints, well, literally means that the butt of the part, and then overlap joints is literally overlapped, and then the second one is molded or shaped joints. So the butt joints means that you have elements, the whole element connected each other, like the whole element, it's only the whole element and then stick together. It's like an attachment, and you can use glue or bolted connection for this, or for the metal, usually we use welding. So this is the butt joint. So each part is still in its own form, but it doesn't overlap. So just try to stick the edge of its element. This is the example, like you have these joints, this type of joints. So it's just directly stick together the part. And then this one is you cut it into diagonally so that it can stick that way. So it has there is no one overlapped. So it's still considered as a butt joints. And then for the what is it? For the steel, usually for the metal, when you have the butt joints, you have to have a welding here, and it gives you additional part like this one here. These additional things. This is like, it acts like a glue for the connections. So you have additional part here. This is how you combine metals on the butt joints. While for the concrete, you just stick with it, just put it on the old concrete with the new concrete. But for the butt joints, it's it is only applicable for floors, like the ground floor, because it's impossible. Just imagine if you try to build, maybe you want to extend your building, your ground floor is possible to be expanded with the new concrete by additional concrete with the butt joints. But if you try to expand the first floor or the second floor, then you have to think about other possibilities, because it's impossible to just stick them like the butt joints here. So you have to add more additional third party that creates the strength and support each other, which is like anchor like this. So this is butt joints. Literally, butt joints is connecting the butt. So the edge is connected each other and attached. Next is about the overlap joints. It's easy because it's overlap means that each element is still having their own shape, and it's overlap, so that the only possible thing that you can do is just try to tie it down. For example, give a tie like this, or maybe bolt it, or maybe give glue inside each part so that it's overlapped. Overlapped is used usually to create, if you don't want to have you want to create more efficient system that works well, because sometimes when you have this part of connection like this, if you push it like this, if it's made of glue or whatever, it will collapse, right? So it will detach from each other. It's also the same. While this one, because it's overlap, so that it can hold each other, and then when you push it, maybe it will move, but it's not detached. It will move, but it's not detached. So the system is that still. This is an example, as you can see here. It holds down the, so this part is holding on this part, the bigger part here. And then for the steel or metal, you can see that if you want to do the overlap one, you can use it. But again, still you have additional part here to attach each other. And then next, we have the last one is molded or shaped joints. Again, if you find it in your furniture, sometimes usually in bed frame, you have this part of molded or shaped joints, usually also used for wood structure that has to be connected each other. So, well, actually you just make mortise and tenon. It's like a puzzle, so that you can just insert it. Sometimes you add more you add more strength by bolting it, or give another third plate when it is connected, and then just add plate here so that it doesn't move around. But actually, when using this, is actually sufficient enough, depends on the load that is imposed to the buildings. That's the explanation. Sabira, is that clear?
It's clear, Bu. Thank you.
Okay. Now, is there any more question? No questions. Okay, right. Now, I will discard this one. Now I think I need to ask you some question related to this lecture. So first question, I hope that, who else we haven't asked? Oh, maybe Fania. Fania, would you mind to explain to me what is the consideration if you want to build a structure?
Wait. The arrangement, the types of connection and supports, and the allowable stress of the materials.
Okay. Is there any question? It's a simple question and has a simple answer if you understand. So what is the consideration on the building construction? Other? Oh, Someone is leaving. Maybe Naufal, what do you think about the question?
Sorry, Bu, can you repeat the question?
Okay, what is the consideration you have to take for building construction?
I think the type of construction.
Mm-hmm.
Just
Is that it? Okay.
yeah.
Okay. Other answer maybe? Someone want to answer the question? Maybe Fari?
I think the strength and the resistance of the structure.
Okay. Other question? Sorry, other answer? Maybe?
Maybe the structural analysis consideration and structural design. They consist of the arrangement, structural design system, like such as system and materials, arranging. There's also interconnection, sizing, and proportioning.
Okay. Okay. Thank you, Sukma. You have read my my conclusion of this lecture. So yeah, again, when we are talking about building construction, there are two considerations that we have to take into our design. First is the structural design itself, and the second is structural analysis. Because the structural design, you design the structure itself, you plan this the structure, and then after that you don't leave it behind. You have to analyze that, because if you just try to design the structure and then leave it behind, then you never know whether it is suitable for your building composition or architectural composition or not. That's why structural design should not be separated with the structural analysis. Again, those are the two things. So now, what is the difference between the structural design and the structural analysis? Anyone want to answer? This is very easy question.
Maybe I could answer. So structural
Maybe
design.
other than you, Sukma, give another student chances. Okay, maybe Fariza. Oh, wait a minute. Yeah, Fariza.
Excuse me, Bu.
Mm-hmm.
What was the question?
Okay. What is the difference between the structural design and structural analysis?
Structural design is a search for a structural system that can meet not only to the load, but also to address with the architecture.
Mm-hmm.
And while the structural analysis is more into the typology of the site, and yeah, I'm not sure. Sibu.
Okay. Any other answer? Maybe from Cindy?
Is the question the difference about structural analysis and the structural design?
Yes.
I think what I've written, I think the structural analysis is more into the arrangement and the dimensions of the construction of the construct, while and also the connections and supports utilized within the building, and also the not to mention the materials and allowable stresses applied. And I think for the structural design, I think it's more technical because it focuses more on the architectural system of the building. I think that's for me.
Okay, so there is a definite differences between the structural design and structural analysis. Anyone can answer this? It's very simple answer, I think. Anyone can answer this. So if you know what the definite differences between structural design and structural analysis, then you can answer it. Sukma, do you know it?
Maybe structural analysis is determining the ability, which is the work of the engineers, while the structural design is arranging the interconnection, sizing, and proportioning, such as determining the grid or the elements. Maybe that's that.
Okay. And the other question, so this is very simple thing that you have to understand to do your assignment. So what is the difference of structural design and also the structural analysis? Because next you have a case study project that you case building that you have picked to be analyzed, and it involves two of this activity, which is structural design and structural analysis. So what is the major difference between these two? How the process work?
Maybe
I can answer.
Yeah. Okay. Noval or Sabira? Okay, you can answer it, Noval.
okay. I think analysis is more into problem, into investigation of the problem, and the design maybe to concepting or conceptual context solution of the problem.
Okay, maybe Sabira.
Maybe from the for the structural design we start from the dari bawah ke atas itu loh, Bu. And for the structural analysis we start the construction from the top to the ground.
Okay, so yes, the structural design is work from the bottom to upper part, while the structural analysis is going from the top to the bottom. Why do you think so? Why you should work the structural design from the bottom to the top, and then the structural analysis from top to bottom? Anyone want to answer my question? Maybe Hisham? I think Hisham is freezing. All right. So maybe Fariza, what about why should we work a structural design from bottom to upper part, and then why should we work the structural analysis from top to bottom?
Maybe because to be sure about the ability, about the supporting structure of the building.
Other question, maybe Nadia? Other answer, sorry.
I think so too. For structural design, you consider the agility of the building from bottom to upper part. For analysis, I think you see from upper, you see like from upper part to the bottom, like that's what you see firsthand. That's my answer.
Okay, so basically why do you do structural design from bottom to upper part is because it's directly related to the element that you have to use for the building construction itself. That's why when you are talking about those elements, when you try to build it in real life, it's impossible to start from the top, right? So you have to start from the bottom so that you can add more layer on it on next level and next level. While for the structural analysis, the activity is actually is trying to search the ability of the structure to stand the loads. Means that we have to analyze the starting point of the loads is coming from the top, because the end is in the bottom, where every load, every forces is going to be transferred into the soil or the hard soil. That's why we talk about structural analysis from top to bottom. That's the two differences. Again, this process on building construction, you have to understand why you should work it on the bottom to upper part, and or otherwise for the structural analysis. Because if you don't understand why you should work that way, it is possible for you to draw it from the top. When you draw your two-dimensional or whatever two-dimensional illustration, for example, section, it is possible for you to draw it from the top. While to understand that is when you try to create the design, try to build it from the bottom, because in this way you can imagine how you build it. So those are the differences between the structural design and also the structural analysis. I think other type, the joints is a little bit you have to memorize that, the butt joints, the overlap joints, and also the shape joints. But I want to ask about the support or the connections, which is hinge, and then also hinge or pin, roll, and also one more fixed. So according to my explanation before, if we want to create column and beams, which connections or which support is the best way to be adopted for column and beams for our building? So which joint that you think? I think all of you need to answer this. So if you want to create two-story building, and then we use column and beams, so column and beam systems, which joint that you think the most applicable one and the most suitable one to create the efficiency of the structure? Is it hinge or pin joint? Is it a roll joint? Or the last one, fixed joint? Just answer it on the chat box. All of you need to answer that. So I wait for it. Only one answer. Hisham is answering directly on my private message. It's just put it in the public chat, okay, so that we can understand each other answer. Please try to not copy your friend's answer. Okay, pin join. Okay, other answer. Only two? Only Hisham and Nadia? What about other students? If you don't write it down, then I will ask you to speak. Mm. Okay, there's no more. Okay, so I will ask, what about Fariza? Which joint do you think appropriate for the structure, the column and beams that we use for two-story building? Fariza? Fariza? Okay, I will be back to Fariza, but now maybe Cindy, which joint do you think? Cindy?
Hello?
Yeah.
Can you hear me?
Yeah.
Suppose it's, I don't know, it's from my opinion, judging from the picture itself, I think it's the overlap joint because it can connect every elements and those elements can bypass each other.
Okay. Okay. Fari, now what about Fari? Fari? Fari?
Ya, Bu.
Okay. So what is the answer? So which joint is the most appropriate one if we want to build a two-story building and use column and beam as the supporting system? The options is pin joint or hinge joint. The second option is roll joint. And the last one is fixed joint.
I think use the fixed joint, Bu.
Pardon? The what?
I think it's use fixed joint.
Okay, very fixed joint. Okay. Another answer, maybe Rafi.
Yeah, Bu.
What is the answer?
Honestly, I'm still confused between pin or hinge joint and the fixed joint.
Okay. Wait a minute. I have to write it down. Next, Sabira. What about Sabira?
I think it's a fixed joint, maybe because it's more restrains the movement.
Okay, thank you, Sabira. Next, Fania.
I think it's fixed joint because it can resist from almost every direction.
Okay, next is Sabrina. Oh, Sabrina is saying that she is with her mother. Okay. Maybe skip Sabrina and then goes to Naufal.
I think it's fixed joints, Bu, because you're able to resist vertical and horizontal moment load.
Okay. Nadia already answered my question. Last one is, not last one. Sukma, what is your answer, Sukma?
I think personally, it's fixed or rigid joints because it could retain the angular relationship between the joint elements because it uses the slab columns and slab. I think it has to retain its angular relationship. And I think because it could retain the vertical, horizontal, and moment load.
Okay. Last one is Fariza. I haven't heard your voice, Fariza. Fariza. Fariza, are you just going to the Zoom and leave it behind? Fariza? If you don't answer me, then I will cancel your attendance today. Fariza? Right, okay. So let's keep Fariza then. So I think there are several answers here, interesting answer, because maybe you are distracted by my explanation related to hinge or roller joints that I mentioned before by using the column and also the beams. Well, when we are trying to incorporate the joints or the support in our building, we have to consider what it is used for. So if we want to build two-story building, it means that it has to be standing, the column and beam will support the upper part so that it has to stand by its own like that and hold the geometry and for avoid the deflection or also deformation of its shape. That's why we are trying to resist all the load that happenings on those type of joint that we have to we want to employ to our building. Again, before I went to the answer, I want to ask you again, what is considered as horizontal load and vertical load, as and then what is moment force as well. So is there any explanation of that? So someone who already answered the fixed joint, and you mentioned that it can resist all the forces or all the load, whether it's vertical and horizontal and also moment. So what is those load actually in real life? Where is it coming from? Vertical load, for example, where is it coming from? Vertical load.
Life and death load.
Okay, life and death load. What is life and death load? Where is it coming from, Cindy?
It's the vertical force, right?
Yes, but I mean what is the cause of vertical load itself? Maybe someone want to help Cindy? What is the element or the substance that create the load for the vertical one?
I think the vertical load may be the roof, or if there's a second floor.
Okay, thank you, Fania. Other answer? You mentioned about life and death load. So what is life and death load?
I think life loads comes from the human inside and the furniture, if the furniture is being moved, and the dead loads comes from maybe the columns or the slabs.
The columns and the slabs. Why the column and the slabs giving load, Sukma?
Oh, I'm sorry. Wall. I think it's the load-bearing wall.
Load-bearing wall. Okay. So the answer is almost correct. But again, the life and death load means that, okay, it's coming from first the people who inhabit the building, and the second death load is coming from its own weight, the structure own weight, because of the gravity that pulled down the weight. That's why we called it death load. Those are the vertical load, because the gravity is pulling us down, so that it's called the vertical load. And what about the horizontal load? What is the horizontal load? The horizontal load? Horizontal load? Okay, Sim.
I think
lateral load.
Okay, lateral load. Okay, ada Hisham. Okay, you want to answer?
I think it comes from the beam.
The beam? Okay, other answer maybe?
I think the horizontal load can come from the wind from outside the house.
Wind, okay. For lateral load, what is it about? Other answer?
I think lateral load could come from earthquake.
Okay, yeah. So I think it's a lot easier for you to understand the load then. So the lateral load is coming from the earthquake, and the horizontal is literally coming from the horizontal direction for the load, can be wind or maybe the earthquake itself. So in buildings, for example, we want to build a specific type of building, such as two-story building, and then we are using column and beam. We want to avoid first collapsion because of the horizontal load, such as people inside, for example. When you, I think, what year is that? 2018 or 2019? There is a news about building collapse in Jakarta. I forgot, like a governmental building collapse. Do you know that one? Do you know that news? Or you haven't heard about
Yes,
that news?
Bu.
Okay, so that
It's
news.
terrible.
Okay, that's how the life load affecting those structure. So that those called the vertical load. That's why when we are talking about the building, two-story building, then we have to think about how to resist the horizontal load. And then for the horizontal load, when you take a look at the joints, which has resistance to vertical load, then you can choose between fixed joints, hinge joints, and also roll joints. But again, oh sorry, only pin joint and also fixed joint. While again, other than that, in building, we have another load, which is horizontal load. In this way, for avoiding the horizontal collapsion, and you have to think about the joint that provide the horizontal resistance, which is fixed joints and also the pin joint itself. Still, there are two, this one. But the last one, why we choose the fixed joint? Because in beams, if you have if you have those type of beams, well, actually, I want to ask you to practice this in the next meeting. When you try to understand the beam like this, when you give a certain force like this part will be like this, right? The logic. When you try to maybe use your plastic ruler or sponge, if you give a grid here, the grid underneath will span. Like this part is bigger than this part. Do you get what I mean here? When you push it, do I have something elastic here? Do you understand here?
Yes, Bu.
Okay, so I don't have to try give you example on this. Here, what happened is actually compression, because it compressed to become smaller part, because it's shrinked. That's why it's compression. While this one is become tension because it's stretched out. The down part is become stretched out. When you have those two type of forces or action here, then it comes. There is a turning point. You can have a turning point. That's called moment. So that's why when you try to build a house, it's impossible for you to have something that can move or flip around. That's why the only possible thing that you and the appropriate joint for beam and also column for two-story building is the fixed joint, because it blocks all type of forces or resistance from the loads that are imposed to the building. Is that clear now why you should use fixed joint? Is that clear?
Yes, Bu, it's very clear.
Okay, so again, how you try to define your structure or your join or connection of your elements that you want to use for your building. First, try to analyze the load that is imposed to this building. For example, if we are talking about two-story building, we are going to use beam and columns, then we have to think about what it should resist on or react on. So for example, we mentioned about the vertical load, we mentioned about the horizontal load, and also the moment, because the beam itself has to sustain itself so that it doesn't turn over. And then that's why you can select the joint based on that. For example, another example is maybe you have a cantilever or maybe a cable structure. Then you have to think about what the forces or the load that they have to resist. Then you can find or you can determine the joint or the support that appropriate for the building itself. I think that's all for the explanation. For the building process, to be honest, it varied from any other country, from Indonesia, or maybe you went abroad. If you did your exchange, it varied from each country, because each country has their own regulation and also they has their own practice. So it is for you, there is no shortcut points for you to understand all the type of construction, but you just hold on to the rule of thumb that you start from the bottom for the design and then goes to the upper part. And then after that, try to analyze the load imposed to this building or those assembly from top to bottom so that you understand how it works. And then try to match between what is available on the local practice, such as for Indonesian, we have those type of what I mentioned before. And then for European country, you will have different type of configuration, but the rule of thumb is almost the same. So when you try to take a look on, I think in YouTube, there are a lot of people who try to build mini house from literally from the concrete and also brick that is very little. So you can try to see those type of videos to grasp the understanding of building two-story building or maybe other building that you want to see, because maybe a large scale is impossible to document because it needs maybe years to build. But for the smaller building, you can take a look at those type of video because it becomes one of the hobby of some people on YouTube. So you can take a look on how they try to assembly each part of it. I think that's all. If you have any last question, you can raise your hand and ask me the question before I close the class. Okay, no question. Because next week is holiday. Maybe Pak Ngurah want to add some information for the assignment or next week meetings, Pak Ngurah?
Yes, I just would like to remind you that you have to, make a progress concerning the task that has been given by us. So I don't know how much progress that you made until now. Can you give us any information about it?